This is 9.5. This is 9.5. Okay, we're going to talk about alternating series. An alternating series. Everybody just drop your pencils real quick. Do you notice how we have -1 to the n in this series? Or -1 to the n plus 1 over here? So what does it mean if we're alternating?
Positive.
Positive, negative, positive, negative, positive, negative. Okay, keep writing.
Positive, negative.
Negative, positive.
Positive, negative.
Think about the positive before you think about the.
Could it be positive, negative, negative, positive, positive, negative, negative? Is there anything that does that?
Yes,
Oh, really?
but that would not be a true alternating.
One.
The alternating series test is actually pretty straightforward. If you have an alternating series, should be obvious. You need to check to make sure that the limit towards the non-alternating sequence goes to 0. We do that anyway, right? 10th term test. Okay. And you need to make sure, what does this mean?
The second term is smaller than the first term.
Oh, what do we call that?
Non-increasing.
Non-increasing.
Okay,
Well, it
we-
says
yep.
equal, so.
It's true.
Decreasing. We
But
call
it
that
could be equal,
decreasing.
So it could be non-increasing.
We call that decreasing.
Well, it's not decreasing, it's.
Why
saying
is that?
Ah! It's okay. We're all right. We're all correct.
equal. So we could write either. Or do we not have to write?
So we're gonna check for decreasing, and then we just have the understanding if like the first and the second term are equal, that's okay.
Are you new here?
Wait.
Are you sure? I think. Yeah.
She did it all the time last year.
I remember that.
Someone.
We
like that.
Yeah, it's just a drop your pencils last year, you just throw it. Where is Josh?
Lincoln. That's some jazz thing, I think.
Is he gonna be a jazz musician for his job?
Magician.
A musician?
A magician.
A jazz musician?
Hey, I'm recording and the microphone's right there.
Say hi to Josh.
Hi, Josh.
Hi, Josh.
Yo, Josh. Hi, Ruby.
Josh, are you gonna be a jazz musician?
Okay. So we are gonna add to our list the alternating series test. Should we try it out?
Yeah. Is this an example?
This is an example
Okay, I was unsure.
because I didn't write example.
Yes.
She doesn't usually write examples.
Yes, she does.
She doesn't.
She writes like a number by
Sometimes.
it.
Only sometimes.
All the time she does.
Not all the time.
No, not all the time.
All the time.
Basically,
Because she always writes a number.
What?
Are you new here?
Notability.
no.
It's what Miss Cronky uses also.
What is
Miss
it?
Conky use?
She's writing on her iPad, just like me, isn't she?
It's usually like the same size.
Okay, so is this an alternating series? Yes. What would the non-alternating piece be? 1 over n. So we need to check two things. We need to make sure that the limit as n approaches infinity of a sub n is 0. Is that the case? Cool. Number 2, we need to make sure that this is decreasing. How would you like to do that?
Just plug in numbers.
No. We have 3 options. We have 3 options. We have the ratio, the difference, and the derivative.
Oh, that was like.
Okay, seriously, people, the derivative is super easy. Can we just do that?
Oh, oh.
Just of a sub n. Nope, just of a sub n. Why is what? Okay. So this converges by the alternating series test.
There's one more after this.
Nope,
2 more.
2 more. 1 day filled with 2 more.
Yes, we'll be back.
No, then we're only halfway through. Then we talk about Taylor polynomials and power series and Taylor series, and I know, I'm like speaking gibberish. I know. Right?
Who is Taylor? Are they new here?
Is she the rapper?
Taylor Swift.
She got the series.
Next one.
Oh, we're doing the ratio test today.
No. Ratio and root tests are Monday. Hey, are you writing this down? Yeah, okay. Dane, is this alternating? You betcha. Look at that right there. But a sub n would just be considered 1 over radical n. Right? Okay. So part 1, limit as n approaches infinity of a sub n. Aiden, what's our limit? Yeah. Woohoo. We show it's decreasing. Evan, do you have a preference on how we do that? Derivative sounds nice. What, -1/2 n to the -3/2? Guess what? That's always going to be 0. Or, excuse me, it's always going to be negative. Then it diverges. If these aren't met, then it diverges. So like if you have one where like number 1 doesn't work, well, that's basically the nth term test, right? But yeah, if either one of these conditions isn't true, then the alternating series will diverge. Okay, so this converges. Now, does this bother anybody? That this was basically 1 over the square root of n times -1 to the n. That doesn't bother anybody. Well, what's true about the series of 1 over square root of n? What's true about that p series?
Diverges. It diverges?
This one was,
Yeah.
yeah, but this guy converges.
What?
Math is not. It's not.
What about statistics?
Those of you taking statistics, you have definitely opened up some doors for your future. There's a lot more majors that require statistics. There's a lot more careers with data science than there were 10 years ago. What?
Except like terms.
Okay, is this an alternating series? Okay, and a sub n would be considered. Factorial.
Yeah, it's factorial.
Factorial. I had a class that just said n. Yep, it was real annoying. Nope. What's our limit? Okay. So I'm gonna go ahead and say that we're not gonna do the derivative to show that this is decreasing.
But we know that it converges because yesterday's homework.
What? No. Oh. Okay, so we can do the ratio test. What needs to be true about a sub n plus 1 over a sub n if this is decreasing? Which one? Okay, so n plus 1, whoops, 1 over n plus 1 factorial over 1 over n factorial would reduce down to what? Yes, 9.1. Which is less than 1, which means we're decreasing. So 9.1, there are 3 ways we could determine whether a sequence was decreasing. We could use the difference to compare to 0, the ratio to compare to 1, or the derivative to compare to 0. You know what? I'm going to, it's true. You learned through the video. See? Ratio. This, you see it right here? That's what you were asking me about. Yeah. Example 4. Oh, interesting. Did she really? Well, you haven't learned it yet. Ratio test is Monday.
But we just used it.
No. Is this alternating? Why? Okay, what's the cosine of 1 pi? The cosine of 1 pi is 1. What's the cosine of, nope, -1. What's the cosine of 2 pi? Cosine of 3 pi. Okay. So, how do I write this? -1 to the n. Nice work. Rachel says it diverges. So let's first check the limit. What is a sub n? Oh, what's the limit towards 1? Or limit of n? What's the limit of 1 towards anything? 1, which is not 0. Now you can say alternating series test, but since we just did the limit and it wasn't 0, you could also say the nth term test. Right? Okay. Okay, so now notice how I want to come back to this one, and I apologize, I'm sort of losing my voice. We talked about how this one was a divergent. Oh, it's there. Okay, I thought it wasn't moving yet. We talked about how this one was a converging alternating series. However, if we didn't have the -1 to the n, it would diverge, correct? Okay, so we can call our alternating series either absolutely convergent or conditionally convergent. Absolutely convergent as long as it converges with or without the alternating piece. Conditionally convergent means it's only converging because it's alternating. It's already 2:14. Jeepers creepers. Okay. That's right. So in your homework, on your quiz, you will be asked to tell me whether a sequence series is convergent or not. Specifically, I could ask you to take an alternating series and tell me if it is conditionally or absolutely convergent. Okay, so let's come up to this one from before. We already determined that this guy was a convergent alternating series, right? Because number one, the limit as n approaches infinity of 1 over radical n was 0. And we talked about how the derivative was always negative, so it was decreasing. Now, if separately we look at the series without the alternating piece, we would say that this is a divergent P series. Would you agree? Because P is less than or equal to 1. So we can say that this is conditionally convergent. Do you see what I'm saying there? It's only converging because it's alternating. Without the alternating piece, it diverges. No bueno.
So if we use the alternating series test, do we have to then specify it's conditional?
I will be sure to specify that if I want that additional piece. Okay. All right, let's look at this one. All right, in the sun? Okay. Grace, do you see we have a new one? Okay. You think so? Andre's calling it absolutely convergent. Okay, so let's first of all just talk about the alternating series test. Is the limit as n approaches infinity of a sub n, is that 0? Andre, how do you want to determine if this is decreasing? Sounds good. You shook your head. You shook your head, no? You need to show me. This is like your worst nightmare, having to show all of this work. I don't like to think of it like that. Okay, so this converges by the alternating series test. Now, let's talk about 1 over n plus 1 squared. Dane, how do you want to show if this converges or not? Don't say integral test. That would be a poor choice. What would you want to compare it to? Okay, so less writing, I could just take the limit. Okay, so this series converges absolutely, because whether it's normal or in the absolute values, like we take the negative piece away, it's still going to converge. Okay, so we have one more thing to talk about, but just make sure that in your homework you pay attention to whether they're asking you for the additional absolute versus conditional, or if they're just asking you, hey, does it converge or not? Okay. Now, last but not least, we can talk about an error in our approximation. Okay. An alternating series, if you think about it, so just everybody just like drop your pencils for a second. If we think about an alternating series, if a sub n has to have a limit towards 0 and decreasing, then it's gonna oscillate while getting closer and closer and closer to the x-axis. You see what I'm saying? Okay, so if we take a certain amount of terms to approximate the entire infinite sum, we know how close or how like the maximum error we're gonna have in that. Write this down and I'll talk about it later. You know what? Today, all of my students I feel have been not all there.
Except us. We're down there.
I feel like we're in it as much as we usually are. No, I just like
Except for,
all
I know. Hey, and we all are done with math
forever.
after this class is, like, you guys gotta go home. I don't, but you can go home after this, like in 4 minutes. Push through. You can do it.
Watch it.
Yeah, he has, yeah, he has early release now. All 9 of you have early release now.
Is that like the first time?
Yes.
I feel like they should have moved this one earlier because we all have double.
Well, but when they created the schedule, we had some kids in academy.
In our class, in this class,
Oh, Ruby was in academy.
what happened? Not anymore, she dropped.
But she was first semester, wasn't she?
She didn't do that, she said. But she didn't. Yes, she did. Not us.
Oh, Aiden's in the academy.
I am.
He's in morning though,
Yeah.
so we still have done early, double. We went at 4. Fifth hour.
Okay, so S is talking about the infinite sum. So the sum of all of the terms to infinity, okay? We don't know what it is, but we can use a partial sum to approximate it. So the actual infinite sum differs from the partial sum by no more than the next unused term.
The big N and little N different.
So this is like a term, like the nth term. This is the sum of 1 through n terms. So not really.
Same like.
It's the same concept. If you would like to, yeah. Okay. Oh, are we? Hey, we're gonna do an example. So can you just like wait?
You start discussing the
It's about to, but can we do the example before the bell rings, please? And then I'll come back to this. Okay. So I want to approximate the sum using the 6th partial sum. So the 6th partial sum is, I'm just going to tell you, 0.63194. That's the first term plus the second term plus the third term. So it would be 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus 1 over 6 factorial.
Did you just?
Yeah, in my head, for sure. Now, yes. The 7th term is 0.0002. Okay. So our infinite sum is going to be between our 6th partial sum plus the 7th term and our sixth partial sum minus our seventh term. This is our max error when we use the sixth partial sum. So we're pretty darn close, just adding 6 terms together.
So it always says like how many terms.
Yeah. So the error in our approximation is always the next unused term. We approximated the sum using 6 terms. So our error is the 7th term.
So like
Be gone when you want to.
that would be the problem. Like that's the word.
Yeah.
Okay. Did you go back up to the top? Oh, like
Uh-huh.
Can I just answer right now?
It's up to you. That's up to you. It's just like that's like basically what I just said, but in words. So you do you. It's Friday. Have a good weekend, but make good choices.